Student, today we will learn the chapter differentiation. In the previous video, we have already described about so many things about this topic differentiation. What is the limit, continuity, after that meaning of differentiations, and by first principles we have derived so many formulas. Now today we will do some questions on first principles and then we will use the directly formula that we have already learned. So basic concept will be completed by doing some exercise. Okay, so now the question is, I am doing so many questions in today in this lectures, so you will be must understand the previous topic better. Okay, so differentiate the following functions with respect to x from first principle. Okay, now question is differentiate the function using first principle. Okay, so now first question is y equal to e to the power x square. We have already learned the formula of first principles, that is dy by dx equal to fx plus h minus fx upon h tends towards 0. Okay, so this is the RHD, right hand derivative. You can also use the left hand derivative. This formula will be used here in these questions. So many formula we already explained. Okay, so we are not doing the formula, we are doing some questions. Now using this we can write d by dx of e to the power x square. We can write here fx plus h. So it is the meaning is that taking the e to the power x plus h whole square minus ex square upon h tends towards 0, fx plus h minus fx upon h tends towards 0. Now we have to do the limit of this. So many methods we can use the limit. So now if I am explaining this, let it is x square plus 2xh plus h square minus ex square upon h tends towards 0. Let we can write here ex square into e to the power 2xh plus x square minus ex square upon h tends towards 0. Okay, so now taking here we common ex square, we can write e to the power 2xh plus x square minus 1, okay, upon h tends towards 0. Now we are going to be use the formula as we have already learned in the previous limit, e to the power x minus 1 upon x tends towards 0, that is equal to 1. So using that concept we will have to here 2x plus h square (2xh plus h square) Okay, this x square is taking common here, 2x plus h square minus 1, so we have to divide it by 2xh plus h square and multiplied here 2x h plus h square and dividing taking here h. Now going to limit here, we can write this is equal to 1. Okay, so we can write ex square into 1. Now taking h common, 2x plus h upon h tends towards 0. Cancel out this and putting the value of h here, we can find ex square into 1 into e to the power 2x plus 0. So e to the power x square into e to the power 2x. Two x plus 0, right here 2x. Here is 2xh plus h square, taking h common, h is cancelled, so we left here 2x plus h. Putting the value h, we getting here only 2x. Okay, so 2x into x square, this h is cancel out. So this is your required answer. Okay, now if we want to do these questions directly, we will do it directly. And how we can do the directly, I will tell you later on. Okay, these all questions I will tell you later on how we will get this answer directly. But here I am using first principle. Right? So question next, y equal to e to the power 2x. Find differentiate by first principle. Find dy by dx using first principle. So we can write again dy by dx e to the power 2x plus h minus e to the power 2x upon h tends towards 0. Same method we are taking here common, e to the power 2x into e to the power 2h minus e to the power 2x upon h tends towards 0. Okay, so we are taking the common e to the power 2x e to the power 2h minus 1 upon h tends towards 0. So multiplied here 2 and here 2. So now this is 1. So we can write the answer is e to the power 2x into 1 into 2. So your answer is 2 into e to the power 2x. Okay, student. So this is using the first principle we are doing the questions, right? Now we have to do next more questions. Now do the questions using first principle. Find dy by dx of e to the power sine x using first principle. So we can find here dy dx of e to the power sine x. We can write here e to the power sine x plus h minus e to the power sine x upon h. H tends towards 0. Now if we are taking the common e to the power sine x, what left here? E to the power sine x plus h upon e to the power sine x minus 1 upon h. H tends towards 0. Again we can write here that is e to the power sine x plus h minus sine x minus 1. This should be understand. Power is subtracting here e to the power m upon e to the power n. So m minus n. Okay. Now dividing here by taking here h. H tends towards 0. Now dividing here by sine x plus h minus sine x and multiplied by here sine x plus h minus sine x. Now if this is y and this is y and y tends towards 0, okay, so this is value of this is equal to 1. So we can say here let y equal to sine x plus h minus sine x. If h tends towards 0, then we can see here sine x minus sine x equal to 0. Hence y tends towards 0. It means this is equal to 1. So we can write here this way e to the power sine x sine e to the power y minus 1 upon y. Y tends towards 0 upon h. We can write this h here. Sine x plus h minus sine x upon h. H tends towards 0. So we can write e to the power sine x into 1 and we have already used these questions in the first principle in the previous video. Now I am doing again 2 cos c plus d by 2 sine c minus d by 2 and dividing by h, and here also we can take 2 and 1 by 2 taking h limit. This cancels h. Now this is 1 and this 2 is cancelled from here, and putting the limit here we get here e to the power sine x cos x plus 0 upon 2 into 1. So your answer is e to the power sine x into cos x. Okay, this is the first principle we are using. Now do more question. Using first principle, prove that dy dx of 1 upon fx is equal to minus f dash x upon fx whole square. Okay, So by first principle, d by dx of 1 upon fx is, we can write here 1 upon fx plus h minus 1 upon fx upon h. H tends towards 0. Okay, so taking the limit here, LCM here, fx plus h, fx, h tends towards 0, fx minus fx plus h, h tends towards 0. Now taking the minus common here and taking h here, we can write minus fx plus h minus fx upon h. H tends towards 0, and taking limit here, fx plus h, h tends towards 0, fx. So we can note down this is f dash x. F dash x means differential of fx, and here fx into fx. So we can say the proving is this, minus f dash x upon fx whole square. Okay, hence proved. So I think you are understanding the so many questions on directly of this point. Now one more questions I have to explain you. Differentiate sine inverse root x where condition is 0 less than x less than 1 from first principle. So your solutions will be this way, d by dx of sine inverse root x, and now using first principle, how you will write sine inverse root x plus h minus sine inverse root x upon h. H tends towards 0. Okay, and now you know the inverse formula, that is sine inverse x minus sine inverse y. What is the formula for that? Sine inverse x under root 1 minus y square means x root x square minus under root one minus x plus h square, root is this square means x plus h into root x upon h. H tends towards 0. So what we got here, let we denoted it sine inverse z, and dividing by z, let this value is z. Okay, and multiplied by z by h, and h tends towards 0, we can see z tends towards 0. Okay, putting here h root x root 1 minus x minus root 1 minus x plus 0 root x, this will be cancelled out, right? So when h tends towards 0, then z tends towards 0. So we can say it is equal to 1. Okay, z upon h, h tends towards 0. Now we have to take here the value of z. So we can find the value of z upon h tends towards 0, the value of z is, and now if taking the value of z, that is under root x plus h under root 1 minus x minus under root x under root 1 minus x minus h upon h tends towards 0. Now multiplied the conjugate of this x plus h root 1 minus x plus, here is conjugate of this, root x root 1 minus x minus h and root x plus h root 1 minus x plus root x root 1 minus x minus h. Okay, so we can say a minus b, a plus b. Using this formula, a square minus b square, what we got now? We get x plus h 1 minus x minus x 1 minus x minus h upon h tends towards 0. Here is root x plus h tends towards 0. And what is the left here? On bracket, open the bracket and solve it. We are getting h 1 minus x plus x upon h. H is cancelled, h tends towards 0, and putting the value here, we can calculate this under root x under root 1 minus x plus under root x under root 1 minus x. So your answer is 1 upon 2 root x root 1 minus x. Okay, so this is your required answer. When you find this directly, this answer using direct method, you will find that it is easier. Okay, so now student, we are going to be some question directly you can understand by this first principle. Now go through direct questions. Y equal to x square plus sine x plus 1 upon x square. We have to find dy by dx. So we have to find differential of this x square plus sine x plus x to the power minus 2. In addition, we know that we have to find the separate of this formula, x to the power minus 2. As already we have described what you can do in addition, subtraction and multiplication and division. So using the x to the power n, that is n x n minus 1, and differential of sine x you have learned in the previous chapter. Okay, minus n x to the power minus n minus 1. So it is 2x plus cos x minus 2 x to the power minus 3. You can see this is a very easy questions when you use the direct method. What are the formula we are using here? X to the power n, nxn minus 1, and differential of sine x equal to cos x. This all formula comes from the first principle, but now we are doing it directly. Okay, so the fundamental is this: if you know the direct formula, addition, subtraction and multiplication formula, then you can solve easy. Now let a question is another question, ax square plus bx plus c upon root x. Now student, this you have to learn. It is a type of numerator upon denominator, means you can use the dividend quotient formula, but you have to care. If the question is simplify in the addition and subtraction form, so first you have to change it in simplify, dividing by root x, what we get here. So you can see here it will be easier before taking the differentiation. X to the power 3 by 2, x to the power half, and c x to the power minus half. So now dy by dx, now a taking common, differential of this is 3 by 2 x to the power 3 by 2 minus 1, taking b constant common, x to the power half minus 1, and taking n is half here, plus c minus half x to the power minus half minus 1. But the formula we are using here, x to the power n, differential is this, n x n minus 1. Okay student, so if you noted down these questions, that first you have to simplify. If it will be simplified, and last you can see this will be 3a by 2 x to the power half minus 1, means 3 by 2 minus 1, means you can take the LCM here, it is 1 by 2 x to the power 1 by 2, and this is a very simple. Now you can take it x to the power minus half. This is a simplification only, nothing else. Okay, minus c by 2 x to the power minus 3 by 2. Okay, so this can be right your answer. So student, if the question is going on simplification, so you have to simplify first. In trigonometry also you have to do this way. So I am going to next examples for taking the different trigonometry part. Now the question is y equal to under root 1 minus cos 2x upon 1 plus cos 2x. Using the simplification formula, you know this is 2 sine square x upon this is 2 cos square x. So we can say it is 10x. 2 is cancel, sine x upon cos x, taking under root. Okay, so it is under root 10 square x, so it is 10x. Now differentiate this with respect to dy by dx. We can say differential of 10x, we have already know the formula is sec square x, and here domain, in the question domain, the value of x is always given. Okay, the value of x is always given. Let here x belongs to 0 to pi by 2 union pi by 2 to pi. Okay, and in including this domain, you can find this answer, so no problem. Okay, if so you have to learn this formula directly, 10x to 10 square x, then that is no problem if you are using this. Okay, so student, sec square x, we are taking here under root, so we can write here, we have to take the differential of mod of 10x, it may be plus or it may be minus. Okay, so if it is positive, then sec square x, and if it is negative, then it is minus sec square x, taking the minus common, 10 square x. Okay, so this will be depend on the range, it is 0 to pi by 2, it is pi by 2, 2 pi. Okay, it is x belongs to 0 to pi by 2, and it is x belongs to pi by 2 to pi. Okay, if this will be given, so you have to check it. If this is not given in the question, write the 10x, answer is sec square x. According to range, if you have to select your answer, then you will be selected. Okay student, now one more questions I am telling you. Let y equal to x square minus 3x plus 2x plus 2. Now you can see this is question just looked in the first look. We can say we have to use the product formula, but in open this bracket we can find in the easy way, that is you can open this bracket. Okay, I am writing the directly answer, x cube minus x square minus 4x plus 4. You can check this, open yourself. So dy by dx equal to 3x square minus 2x minus 4 into 1, and constant is 0. Taking x to the power and 4 in constant outside, x to the power 1, that is 1. Using formula x to the power n, differential is n x n minus 1. Okay, so your answer is 3x square minus 2x minus 4. 3x square minus 2x minus 4. First you have to open and check it, this is or not. So this way, first you have to simplify the questions. If the question will be in multiplication and division form, first you have to write in addition or subtraction form. Okay, then you should use the formula. Now what is the product formula and division formula? On that topic I am going to be do some questions. Okay, now y equal to x sine x. Now we cannot simplify this, so we have to use the differential of this by using the product formula. And you know the product formula is this: differential of first function into second plus first into differential of second function. Okay, anyone may be first or second. Okay, so we can write this, that is differential of 1 sine x plus x cos x. So this is your required answer, right? Now in this product formula we cannot simplify it, so we have to use it. Now one more questions of our product formula we will use. Let y equal to x cube into e to the power x into sine x. Now you know the product formula, that differentiate of first multiplied by second and third, and plus first and differentiate of second and multiplied by third, plus first into second into differentiate of third. Okay, so now using separately here, 3x square into ex into sine x plus x cube, differential of ex is ex into sine x plus x cube into ex, differential of sine x is cos x. So student, it is very easy. Now if you want to take something common as x square, you can take the common, and e to the power x also take the common. It is depend on your choice. Now we have to taking the common, so what is left here? 3x plus x sine x plus there is also x cos x. So this way you can simplify, it is your choice what the question is simplify or what is not simplify. Okay student, now I am going to we tell you some questions on quotient rule. And what is the quotient rule? I have already described in the previous video. Let this, here is a question, e to the power x upon 1 plus sine x. So what is the formula of differentiator of this? With respect to x, ex upon 1 plus sine x. Now you can see it in numerator and it is denominator. Okay, so your formula is, first write denominator, that is 1 plus sine x, and do the differential of numerator minus, and then you write the numerator and do the differential of denominator and upon square of denominator. This is your rule. Now separately you have to simplify this. Now it is 1 plus sine x, you cannot do, differential of ex is ex, and here is addition, so differential of 1 is 0, sine x is cos x, and here is 1 plus sine x whole square. Now you have to simplify only this, taking the ex common. This is your answer, but you have to simplify. 1 plus sine x minus cos x, and you can write here 1 plus sine x whole square. So it will be more simplified, then you can do it, otherwise this is your required answer. In proving, you have to note that you have to simplify up to what you have to prove, but not here. So we have already learned quotient formula, product formula, addition, subtraction. So many questions you have to done on it from your exercise, your book. Okay, so but first learn that if you can simplify the questions, then you have to first simplify, then do the questions. Okay, so in the next video we will do the differentiations of a functions. Of a function means composite functions, so you have to wait for them. Now thank you for watching.